Welcome to my YouTube channel Engineering at Your Fingertips. In this video, we are going to learn about actuators, analog actuators and PWM, that is pulse width modulation. So as we know, IoT devices have a set of actuators that cause something to happen in the real world. Because IoT devices have to do something, have to have some output, right? And the output goes to actuators and they cause some event in the real world. Now this event in the real world might be as simple as putting a message on a screen, right? But it could be more sophisticated than that. Okay, basically actuators are the outputs of the IoT device. So could be visible, maybe it's a LED or a set of LEDs, lights go off and on, LCD, that is liquid crystal display monitor or serial monitor. All these things are output devices and are called actuators. Audio, so maybe it a buzzer or a speaker, so it can make sounds of some kind. Motion, so they can cause motion. Maybe one of the actuator is a motor, that is a common thing to move something in a physical world. A valve or a pump to move water or some kind of liquid to let them pass through a pipe or something like that. Now the simplest type of actuation you have is what I will call on and off actuation or power actuation, and all you are doing is controlling the power. The only control that you have with this device is power. Now this is very simplistic control, so even complicated actuators can be controlled via power. Minimal control, but you can do something via power. So LEDs, light emitting diodes, you can just turn them off and on. Now you can be more sophisticated about that. You can make them brighter or darker and all that, but you don't have to, because you can just say off, on. You can control them in this digital way. A buzzer, you can make it buzz or not buzz, means in everything in 0 or 1, either on or off, no between them, nothing between 0 on and off. Now there are all kind of devices like that. Basically all devices you can give, you could just control them through power on off. Now this is for complicated actuators. Now this for complicated actuators, this doesn't use the full potential of the actuator, meaning like that with a monitor you can put up messages on there, draw pictures on there, all kinds of sophisticated things. But if you are doing on off actuation, all you can do is turn it off and on. So you are controlling it, but in a minimal way with an LED. LED off and on is often enough, but you could make it dimmer or brighter. But with on off actuation, that is not possible. So this is one way to control an actuator, just throw power. On off control may be all that you need. It depends on the application. Maybe all you need it to turn your LED off or on, in which case on off actuation is just fine. Very live example, lights in classroom. Yes, so like in my classroom, when you walk in your room, the light sensor turns the lights on. Just think about when you enter your class, the light sensor turns the lights on, and it doesn't set the lights at a certain dimness or brightness or something like that. It's that either they are all on or all off, so it's sufficient. Also air condition, like HVAC systems, typically like in many digital office, the air is on or it's off, it doesn't get in between, so that is mostly satisfactory. One thing to worry about or to be aware of when you are actuating something, and especially in this power mode, is to think about the current limits of the device, of both devices. So your microcontroller and your actual actuator can vary the current limits, and this will go mishappen to your IoT devices. So for instance, an LED, typical LED might only be able to handle 20 milliamperes. So you can't drive it with more than 20 milliamperes without hurting it. So you got to make sure somehow that that it only driven with 20 milliamps. So for instance, putting it an appropriate resistor in series with LED will using V you know Ohm's law, V equals to IR. So putting it in an appropriate resistor in series with LED wheel, using V equals to IR, you can put the right size resistor to make sure the current never exceeds a certain threshold. Now you also have to think about current limits on other side, on the supply side. So the Arduino, regular Arduino pins, or Arduino, you know, regular pins besides the power and ground, the power pin rather, regular pins can only supply 40 milliamps. Remember this one, regular pins can only supply 40 milliamps. So if you are driving something that need more than 4 milliamps, you may have problem. So for instance, if you got a motor that requests 50 amps, then 40 milliamps is clearly not enough. And I say 15 amperes because I think about many motor devices, quadcopter, and these motors can take 10 amps and 15 maybe. They require a lot of power, and the Arduino would never be able to supply that level of power. So in a situation like that, the Arduino can't supply it. So you need some other power supply. So like on a quadcopter, there is a big fat battery on the bottom, and that is power supply. And our Arduino that we use to drive it, the drive motors, the Arduino doesn't actually directly feed power to the monitor. Instead, the Arduino controls the switch between the battery, the big battery and the motor. So it controls access to the power in that sense. So we will talk more in detail about this in future slides. So you got aware about these current limits. The Arduino itself can only supply certain amount of current. So if you need more than that, you need an alternate power supply. The device that you are actuating, say a LED, might only be able to take a certain amount of current, and you have got to make sure that the Arduino or whatever device it is that drives, it can't supply more current than is necessary that it can take. Thank you for this video. In upcoming videos we will be learning about analog actuators.